welcome, ladies and also gentlemen. I would like to start with who I am. Bart Cremers, I'm a knowledge consultant for the Zehnder Group. And what does a knowledge consultant like me do for Zehnder? Well, I hear and read a lot about ventilation technologies, mostly in science, in the scientific world, and I do a lot of research myself on our ventilation units and technologies. And actually, I'm giving proof of that by doing long-term monitoring campaigns. After that, I also transfer that knowledge in articles or in conferences. That's what I'm doing. And today I would like to give you the results of a monitoring campaign that I have been doing, which shows the comparison between comfort ventilation with balanced ventilation systems, with heat recovery, and I compare that with window ventilation. Depending on the country that we are talking about, the new buildings, the new houses are built either compulsory with a mechanical ventilation system, but there are also countries that leave the choice to the people. And we hear still a lot of people saying, okay, for fresh air in a renovated building or a new building, I can open my window. That's okay. And what I'm about to show you is that the window openings in real life are not enough to give you a sufficient exchange of indoor air and outdoor air. So please join me in my results. We're talking about a multifamily building, and this one is situated in Switzerland. This building was monitored for a full year, and there were 4 apartments were analyzed by me. And what I'm going to show you in 3 parts is first I show you the method of monitoring, then I give you the results in terms of indoor air quality, and afterwards I give you the results in terms of energy. So that is the heating use in winter and the cooling use in summer. We are talking from the front to this building, and the building has these 4 houses, 4 apartments that I have been analyzing. So we have bottom apartments. Bottom left is a bit smaller than bottom right. So bottom left has a living room and 1 bedroom, and the bottom right apartment has 1 living room and 2 bedrooms, a master bedroom and a second bedroom. On the first floor there are, and I call them the top apartments, and these are the same in size, and all these 4 houses are of course conditioned in a way that there is a heat pump providing heating in winter and cooling in summer. In the attic there is a penthouse, and there are also people living there, but this penthouse is not monitored nor analyzed by me, so I have no values of that. But there are people living, and it's a condition, so it's heated and cooled in winter and summer. And also an interesting thing to note is that below the left apartment, in the cellar, there is a children play school, and of course this children play school is also conditioned, so it's heated and cooled. It's different in below the bottom right apartment, because you see here, and I've indicated that with a gray area, that there is a basement there for storage, and the basement also for the installations, so our technical installations are also there. And this cellar is not conditioned, so it's constantly more cool than the other environments. It's outside the isolation, how do you call it, isolation parameter. This is important to keep in mind when we analyze the energy results. When we look from the top to the plan views, I have indicated here below the dashed line how the bottom apartments are looking. So there is the left apartment and the right apartment. And I've indicated with these images that we have a ComFair-Q balanced ventilation system per apartment. So each apartment has one ComFair-Q balanced ventilation unit, providing the fresh air in a constant flow rate. So we have made sure that we have always the same amount of fresh air coming into the house. And the occupants for the first year, so for the monitored year, were asked not to change the flow rate. The family types are also indicated, so 2 people live in each house. And there are also blue circles, and these blue circles, they indicate where there are windows or doors going to the envelope or in the envelope of the house. These windows have all window contacts, so I know for every minute if the window is opened or closed or maybe in a tilted position. And that gives me an idea about the use of windows in all the houses. You see in the top apartment that there are no mechanical ventilation systems providing fresh air. So there the people are relying on the opening of windows to let fresh air in. The family types are almost the same, so also 2 persons in the top right apartment, only in top left apartment is 1 person living. There's one more thing to tell. I can say that with all these windows, I calculate an airing factor, and an airing factor means the percentage of windows that are open at one time. So if I say an airing factor of 100%, that means that all of the available windows in one house are open at that time. An airing factor of 0%, that means that none of the windows are opened. And of course, you can have everything in between. Then the CO2 values, because the indoor air quality is expressed with the CO2 levels. A CO2 level above 1000 ppm is generally known as as an indication that the exchange of air is not sufficient. We have monitored the CO2 values in all the living rooms and all the bedrooms of all houses. Then we go to the comparison. So I first give you a comparison in terms of indoor air quality and then in the heating and cooling data. First, the indoor air quality. I give you first one example day in an apartment with a ComFair-Q ventilation, so that's the left graph, and in an apartment with window ventilation. It expresses one day, so we go from the night, 12 at night, to the morning, afternoon, and then we go to 12 in the evening. The blue line, that shows the CO2 value, and you can see for the mechanically ventilated apartment that the CO2 value is during the whole day between 400 and 600 ppm, showing that there is good indoor air quality this day. In the night it is about 500, 600 ppm. When the people go to work, the mechanical ventilation provides a constant exchange of air, so the CO2 value goes down to the level of 400 ppm, which is more or less the outdoor CO2 level. When they return home, there is a slight increase of CO2. They are sometimes using some windows indicated by the red line, so when the red line goes up, That means that more windows go open, and sometimes they are closed again. But the CO2 level stays below 600 ppm. That's the difference with the window ventilated apartment, where you can see that in the night, for instance, the CO2 level doesn't get below 600 ppm. Although the red line indicates that there are a quarter of the available windows are open, because this expresses 25%. So even though a quarter of all the available windows are open, the CO2 level doesn't go below 600 ppm, indicating that the air exchange is not sufficient. We can also see it during the day. Even though there is one window open, the CO2 level doesn't go down because there is no exchange of air. And in the night, it's totally dependent, or in the evening, I mean, when there is still occupation, it's totally dependent whether people open the windows, then the CO2 level decreases, and when they close the window again, it rises again. So what we can see is that the Comfair Q ventilation brings constant refreshment, even with only one window slightly open. And for the window ventilated houses, they need to have 25% of all the windows open to get to the same refreshment as our mechanical ventilation does. So you have to keep that in mind. But of course, I don't want to say only what it is on one day. I want to show the indoor air quality over a whole year. And I do that making use of carpet plots. And what is a carpet plot? It's a colorful plot which shows from left to right the day of the year. So we are starting the monitoring campaign in July. We are going to the winter, and then we return to the summer again. And from top to bottom, we have the hour of the day. So we start at midnight in the morning, we go to the afternoon, and then we go into the midnight in the evening. The colors indicate the indoor air quality. So green when the CO2 level is below 800 ppm, indicating a good indoor air quality. Red when the CO2 level is above 1000 ppm, indicating a bad air quality. And orange is in between. In this slide, I show you all the carpet plots of all the monitored rooms in all the houses. Again, below the dashed lines are the mechanically ventilated apartments. In the left side, you see that there is a lot of green, especially in the living room, only some buildup of CO2 in the winter, probably at Christmas time when there are people invited for Christmas dinner, and then the CO2 level rises above 1000 ppm. In the bedroom, you can see the day-night variation. So when there is people in the bedroom, when they are sleeping there, then the CO2 level rises, but doesn't go above 1000 ppm thanks to the ventilation. More or less the same analysis can be made for the bottom right apartment. We have one more bedroom there, and you can see when it is occupied, the bedroom, yes or no. We also know with different studies that in such apartments, mostly the master bedroom is the one with the highest CO2 levels, but still the green is overwhelming, so we have good air quality most of the time. It's different when we look at the top apartments. The top apartments, they show a lot of red, indicating that there is a bad air quality and an insufficient air exchange. So probably these people, they use some airing, they use the windows, but not enough to give you the same exchange of air as we have in the mechanically ventilated case. So if you have questions, then please type them in the chat and we will come to it later. The next thing what I do is to count the number of hours that the CO2 level is above 1000 ppm. And why do I do that? That is because that indicates when the indoor air quality is maybe unhealthy. And I show that for each room, and then you see in the red numbers that for the mechanically ventilated apartments, the number of hours with insufficient air exchange is below 100 for the whole year, and the whole year is 8,600 hours. So it's hardly any insufficient air exchange. And how different is the window ventilated case? Because there, let's say 3,000 to 5,000 hours of the year, there is an unhealthy indoor air quality. Some people would say, okay, but maybe the window use is different. Well, when I look at the mean airing factor for the whole year, then we all come to, regardless of the ventilation system, but people use the windows around 6%, 5% to 8% of the year. So if you average all out, then let's say if there are 10 windows in a room, then 10% means that one window is open and 5% means that one window is in a tilted position. So when people say you that window open gives you fresh air, that is true, but only when the window is open, of course. And what I show here is that the window is not open a lot. So you need the mechanical ventilation system to give you the right amount of fresh air. Then people might argue, okay, but with that constant fresh air exchange, does that give you more heating use? Because more fresh air is coming into the room. Well, thanks to our heat recovery, that is not the case. I show you the results, and I show you here the results in the heating use of the whole winter, so the autumn and the winter when the rooms are conditioned, heated. And I show them in values per square meter, of course, to also make a clear comparison between the smaller and the larger apartments. Immediately, the numbers indicate that the bottom right apartment has the most heating use. And without going into details, but I have proof, I can show you it if you want. I have proof that it is an exact heating leakage going to the unconditioned cellar. So only because there is a cold cellar below the bottom right apartment, there is also a higher heating use here. Also, I'm sorry for the plane. There is a military base here. I'm sorry. Also, they have the room thermostat a bit higher, and I have also proven that. What I want to make a good comparison, I have to compare the houses that have the same airing factor, so the same window use. So I look for an airing factor of 5% is here, and the top right apartment has also 5%. So then I can make, for the same window use, I can make a clear comparison between what happens when we have window ventilation and what happens when we have comfort ventilation. And then I show that we have for the heating recovery of our comfort ventilation, it takes you to a quarter lower heating use in the whole year. So thanks to our heat recovery, we bring more fresh air inside the houses, but for a lower heating use, and that's important. I'm also showing in summer what happens with the cooling, because here the heat pump is also providing the cooling. And what we see now is that the bottom right apartment has the lowest cooling use. And that's again because it is situated above a cold cellar. And we call that effect in physics, we call it the neighboring effect or the neighbor effect. So that means that if you have an apartment or a house above or beside or below you that is really colder than your own apartment, then you have a heat leakage to that one and you pay more for heating. The cooling is helped here by the cold cellar. And again, if I want to make a clear comparison between the two apartments with the same window use, then we can compare the two left apartments, and I can come to the conclusion that we have more fresh air exchange with the mechanical ventilation, but thanks to cold recovery, we have also 1/3 less cooling use. And that brings me to the electrical consumption. Electrical consumption of the Comfair Q is not a lot. I have also monitored that, and it shows, without going into the details of the graph, that the average electricity consumption of the whole unit is 20 watts. So that means when you compare it with a 60 watt light bulb, if you light that for 8 hours a day, that's the same electricity consumption as our Comfair Q. Then I come to the summary of my findings. We can see that mechanical ventilation, so the balanced ventilation with recovery versus window ventilation, gives you a much better indoor air quality because you always have the fresh air exchange, you always have fresh air coming into your house, and not only when a window is open. And when you compare it for the same window use, then you also have lower heating use and lower cooling use. Then I would like the last slide to show you how I generalize these results. So not only the findings for this apartment, but what does that mean for other apartments? And I can show that in this 4 pictures. Let's say here we have a house before renovation, or as they were built maybe in our grandparents' time. It was not an airtight building. There was no isolation. So the infiltration of outside air coming into the house was fairly large. That gives you a moderate indoor air quality, but for a high energy use. More and more people are now isolating their houses and making it airtight. But if you don't spend your focus on a mechanical ventilation system, then you only depend on the window use, and that gives you a lower energy use, but it gives you also a very low indoor air quality because the windows cannot give you the right amount of fresh air. Then, of course, you can decide for a mechanical ventilation system. If you do that without recovery, then you certainly have fresh air coming in, but still your energy use is high. And the best of both worlds you have when you have a mechanical ventilation system with recovery. So you have a constant fresh air guaranteed, also filtered, and for a low energy use to make your house warm in winter and cool in summer. I thank you very much for the attention, and I give the word back to the moderator, Pirette.
Yes, hello from my side, and many thanks to Bart for this interesting presentation. When you were showing the table of the, let's say, so-called unhealthy hours, then it was also possible to see that the airing factor for the apartments was rather similar in the percentages. But in some of the 2 of the apartments, we had mechanical ventilations and 2 we didn't have. Is there some kind of a reason for that? Why?
Yeah,
Yeah,
still more or less the same window use. Yeah.
exactly.
I think, Pirat, that this is a consequence of, how do you call that? The power of habit. When people move to a newer house or they renovate, they are still used to use the windows in the old way. So in the old houses, you needed to open your windows to get the fresh air inside. And I think this is still the case in these houses. The people are using the windows as if they need it for fresh air. But as they have a mechanical ventilation system, they should not open the windows for fresh air, but they can, of course, open the windows to chat with the neighbors or to hear the birds sing. And I think it is really, yeah, maybe two generations later that people will start to realize that they don't have to open the windows. They are getting the fresh air via the mechanical ventilation system.
Okay. Okay. Yeah. Thank you. That's a good point to think about. Yeah. That also in the crafts, it was visible to see that usually in the mornings when people get up, then the windows were opened and yeah. Okay. Yeah. And also, it was also not set as unhealthy hours in the bedroom over the night time, but there were also like the orange color indicated on the crafts. Is this something that people should also think then to kind of increase the supply air in the bedrooms, or this is just an indication that okay, that people are staying in the sleeping in the bedroom?
Yeah, that's also a good point. I have seen quite a lot of studies showing the indoor air quality in all kinds of rooms in houses. And what we see, all kinds of ventilation systems, but the bedroom is probably the room with the lowest indoor air quality of the house. And that is the master bedroom because two people are mostly two, or maybe not, but two people are sleeping for 8 hours. So there is a long occupation in that room. And I think it's a good idea to focus on that, maybe by adding more fresh air than before to master bedrooms, maybe with two valves and giving you a right amount of air in the master bedroom. Of course, we have to consider that in this monitoring apartment, we have asked the people
Hmm.
to have the constant airflow rate. They can change later, of course, to a higher setting, or they can choose to purchase CO2 sensors that really control the ventilation system. So when the CO2 value goes above a certain point, then the whole amount is increased, the amount of fresh air.
Hmm. Okay. Yeah. Thank you for this answer. And do we have some other questions, or this is a good time to discuss about the indoor climate um, at this point? But if there will not be any questions, then I would then say from my side, thank you for all the participants. And of course, big thank you for Bart for doing the research and then presenting the results to us. And yeah, from my side, I will wish everybody a good continuation to the Ish Fair.